I want to thank everyone for, I actually think that you wanted to be at a conference so that you could avoid Black Friday. But there are seats empty in the back corner, so maybe people are shopping. So thank you for coming here instead of the sales. I'm going to talk to you about mobile web performance. And the slides are always going to be up at this. This isn't sounding very good. My name is Estelle, and there aren't that many female web developers. There's not that many women named Estelle in the world that are between the ages of 20 and 75. So I actually got my own name. So if you on GitHub, if you ever want to see any of the slides of any of the talks I've given in the past 10 years, and there's over 100 of them, that is estelle.github.io lists all of them. So when I talk about mobile web performance, there is only one web, and it's on all devices. What I'm really talking about is don't break the mobile web. When you're developing sites and you're developing it on your desktop, you might not be thinking about mobile. So I'm going to be pointing out things today so that you always have mobile in the back of your mind when you're developing, and always have performance in mind. So we want our websites, especially on mobile, to be fast to load, fast to render, fast to respond, quick to understand. We also want to be beautiful, useful, and eco-friendly. As developers and not designers, we don't really focus on the beautiful part, but we should be focusing on the eco-friendly part, and I'll be talking about that as we go along. So there's three parts to this talk, kind of. The first is discussing the current ecosystem, talking about concerns that particularly impact mobile, but do impact all websites, and then some issues and solutions. So, the mobile ecosystem. The top devices in 2016, and probably the devices that you as developers own, might be on this list or something similar. They've got over 1 gig of RAM. They have huge hard drives. They've got really fast CPUs, dual core, most of them. And that's what we are developing on, and that's what we're testing on. But the entire world is not online. Right now, this picture is a bit old, so it says 3.2 billion people are online, 1.1 billion being on high-speed internet. The number now is about 3.7 billion. But you'll see that all of these countries still have a lot of people. Even in the United States, we have over 50 million people who are not online. That's more than the entire population of Greece. That's 5 times more than the entire population of Greece. So in Indonesia, they have about as many people who aren't online yet as we have Americans that are online. So, but if you look at Indonesia, they actually could all be online. They have internet access or wireless access. Indonesia is down there in the bottom right-hand corner. The entire country is green because they have access throughout the whole country. Kind of crappy in the middle, but really the population zones, the high density zones, everyone could be online. But this is the devices they're using. Yes! Okay, so we'll get this back up. But basically the devices that they're using are feature phones. 6 out of the top 10 are feature phones. Between $9 to $100 phones. And I'm hoping this will go back up, but maybe it won't. But I can continue talking. Okay, someone's coming. So the highest end phone is on a $100 device or a $140 device. And it has a dual core CPU, like we sell in the United States, and a max of, okay, now my computer is off too. So I'm just going to continue talking. So the phones in Indonesia, they basically, these devices, 6 out of 10 devices are feature phones. They have crappy RAM, and you're talking 32 megabytes of RAM. So that computer that we saw in that first talk today, that had the same amount of RAM as people's cell phones, which sounds like a lot because we could do a lot with that. But when your website is 4 megabytes, and there are websites that are 4 megabytes, the average website is actually 3.6 megabytes. They don't have enough room for their operating system and your website. So when I'm going to do the whole talk without slides. So when I first opened a cell phone that I purchased. It was about 4 years ago. It had 3 gigs of a meg of RAM, and 2/3 of that was used by the operating system and the apps that were by default on the phone already installed. So I had 218 megs of RAM for all of the apps that I wanted to add. Now I can't even see my screen, so I don't even know what slide's next. Okay. I'm just going to skip over. So basically, what the slide looks like that you're not seeing, or why don't I do this? I'm going to show my entire talk on a tiny little screen. It's an airplane. So this, now it's definitely not going to work because it's not even attached. No, it's still not working. So we're basically developing on our computers. Our computers, this one has 16 or 32 gigs of RAM. And we're developing sites for people who have half a gig of RAM. So instead of like targeting the fire, you know, like you're not going to sell your product, and the person on that feature phone is not necessarily going to access your website. But think of developing, like don't think when you're developing on a fighter jet, and the feature phones might be paper airplanes. But think about like as if you were developing for the equivalent of a drone. It's kind of new, it's kind of modern, it has nice features, it can lift a camera or have a camera. But the other thing is, who here has their cell phone plugged in right now? And you're powering it up right now? Okay, we have 2 people. Who here, when they work, is always, like basically, we walk around all day with a cell phone in our pocket, not recharging it. My battery died yesterday, I had to recharge it. I had to carry this huge battery pack and a wire to recharge it so that I would have my map so I could find my hotel on the way home. So the battery in our laptop or on our desktop is basically recharging itself all the time because it's plugged in 50% of the time. It's like a car battery. When you drive, it recharges. The battery in your cell phone is more like a AA battery. You put it in in the morning, and you hope it lasts till the end of the day until you can recharge it again. The thing is, devices now have dual core, you know, like they say, oh, we have dual core hard drive, isn't this amazing, this device is going to be so fast. But the battery that is in that phone is less powerful than a shitty AA battery. I'm not talking about like the high-end Duracell, whatever fancy thing. It's about the size of an Energizer battery. Okay, so we're not even going to, we're giving up on this? Okay. So, yeah, this is fun. This is a good talk. Okay, so the thing with mobile devices is we have these really powerful browsers. The browser on your mobile device is the same almost that is on your desktop. Yay! Okay. So let me just go back. This was the idea of when you're in your development environment, realize that you're not a jumbo jet. Develop for the idea of a drone. When you're on your desktop, you're not thinking about your battery. The battery on a mobile device is like a AA. So here, this is the iPhone, and for some reason the picture of the iPhone is not coming up. But if you see, it has a CPU of 1.8 gigahertz dual core, right? But the battery is 1,750 milliamps. This crappy battery, this is the one that I don't buy, is 2,000. So this battery is more powerful than the Apple battery. Now Apple did some amazing engineering, so it's not draining that fast, but it's not using all the power of that dual core. This computer, when it uses, you know, when I open WebGL that was done incorrectly, it heats up and I get the fan, right? If your phone is heating up, that battery is being drained because that's how it's heating up the phone. So we are developing on these tiny devices with hugely powerful browsers, less powerful CPUs. They're not plugged in. Some people have metered data plans. Like yesterday I got a card for a SIM card, and I could either buy 1 gig or 6 gigs, and it was €2 more for like the extra 5 gigs, and I'm like, I use less than a gig a month, and I'm only in this country for a few days, but maybe I'll need to tether because you never know with hotel or conference Wi-Fi. So I went for the for the 6 gigs. It's a tiny screen, and then there's different keyboard interactions. When you're developing for mobile, or when you're developing on your desktop, you're not thinking about these things, but what you really need to be thinking about is battery, latency, memory, and responsiveness. So let's talk about some mobile concerns. Dawn said, just because no one is using your mobile website doesn't mean you don't need to improve it. Maybe no one uses it because the experience is awful. Not to pull out the last speaker, but the advantage, they did not actually set, when you go to their website, it is so tiny you can't actually read their screen because they didn't actually test it on a mobile device. You need, like if you're having a bad experience on a mobile, like just because no one's using your mobile website doesn't mean that you don't need to improve it. If it's bad experience, no one's going to be using it. Stephen said, I remember when 3G was the primary mobile speed. It was slow, but it still worked. So why now, when my phone says 3G, it becomes completely useless? Let me tell you why. In 2010, let me make this a bit smaller. Oh, that's really working well. Sorry. I make you see the bottom of the screen. Can you see it? Yeah. So in November 2010, the average of the top 1,000 websites, the average website was 626 kilobytes. Right? That's under a meg. That's 0.6 megs. Today, of the top 1,000 websites, the average is 3.6 megs. That is an increase in 7 years, exactly 7 years, of almost 600%. So if you move from edge to 3G or from 3G to 4G, you're like, oh, this should be so much faster. But the site is 6 times fatter. Ooh, I shrank my screen too much. Okay. So I'd like to tell you about this thing that happened at Google many years ago. It was like 2011. It might have been later than that. The date's actually there. It's 2012. Okay, so it probably happened in 2011. The blog post was written in 2012. Someone in their 20% time on YouTube did this thing called YouTube Feathers. They decided they were going to make a really light YouTube, and they set their performance budget of 12 requests. They ended up going to 14 requests. Let me just bring in the side, because you can't actually see the side of the screen. Oops. Okay, whatever. I'm just having a bad day. So it went from 1.4 megs to 120 kilobytes or something like that. And they launched the site, and then they decided to check the stats 2 weeks later. And the average time to download YouTube on this Feathers branch of it went up by 2 minutes. So you're thinking the site is super fast, but the time is going up. So what happened? People in parts of the world that had never accessed YouTube because it was so slow were finally able to wait that 2 minutes to download that cat video, because that is obviously what they were all watching. So the time went up because people in Siberia and Central Africa were actually able to watch videos for the first time because they didn't have all that cruft that they had to download. So that is an example of how people weren't using the website because the experience was terrible. So with web performance, we have to think about the number of resources we're downloading, the time that it takes to parse and execute and paint, and also the user perception, or rather the user perception of how fast your website is loading. I'm actually doing a study, we did a study, and I'll talk about it a little bit later, on perceived performance. So let's talk about some issues and solutions. We know that the number of HTTP requests, going in and out? Okay. We know that the number of HTTP requests, and should I change? Is this going bad? Yeah, okay. Now that all that needs to happen is my computer needs to crash, and then we can have like all of the bad things happen. So there's certain things that we control when it comes to performance. We can control the number of bytes. We can control the number of HTTP requests. We can control the jank of our animations. We can control, and we should control, and make sure that our site can be squishy. Some people call it responsive design. I call it squishy design, because it's basically saying that your site can squish down and squish or expand. That has nothing to do with responsive. Responsiveness has to do with when you touch it or when you press on a button, does it actually react? That's responsiveness. Things that we have less control over is the network latency, the hardware that people are using, and the browser that people are using. So what is involved in the page load? Well, let's not talk about that because that's kind of boring. But just remember that style sheets are blocking, scripts are blocking, do use async and defer. And each request that you put in has to go make like every time you use a different domain or even prefix, it has to do a DNS lookup. When it comes to desktop, a DNS lookup is not a big deal. It goes from your computer to your, you're basically on really good Wi-Fi or even tethered, and it just says, okay, you want google.com, let me go make a DNS lookup and see what the IP address is. Here's the IP address. It's just a back and forth. And then it says, okay, get me that IP address. When it comes to your cell phone is actually, when it makes that request, it's sending a signal to your cell tower, which is then sending the signal to the phone company, which is then saying, hey, they have a modem, they have a DNS, they can look up right there, which goes back to the phone company, back to the cell tower, back to the mobile device, and then you're like, oh, now I know the IP address, and then you have to go back to the cell tower, back to the phone company, back to the server, back to the phone company, back to the cell tower, and then back to the device. Most of the latency happens right where those two, where I put 1 and 2, the yellow, and that's something that you're not really thinking about when you're at work on, a T1 line. So there are things that can impact latency, like having a CDN is a good idea. One thing that impacts latency is having SSL, or having a secure site. It is a negative impact on latency, and it is totally worth those extra 60 milliseconds or whatever it is. It will triple the time of that connection, and it is completely worth it, having a secure site. And then there's something called BBR congestion control, and Google Cloud has that now, and dynamic packet recovery, the place I used to work, was their system. It's basically when you are fetching a site, the pipes that are sending you, where your data is going through, the bottleneck is the fastest it's only going to go as fast as your slowest bottleneck. So BBR congestion control and dynamic packet recovery are basically both systems to make it, to handle packet recovery, basically, and it improves the speed enormously. So that isn't here yet, but it's something to keep in mind in like a year or two when we'll be able to use it. So another thing about, another feature of performance or thought about performance is what Google came up with. They called it Weyl. If you look at the colors, it's actually liar, because it's load, idle, animation, and response to input. Because the load comes first. So you want your site to load fast. You want it to load within 1 second. Who here has a site that loads? But yeah, that takes thinking about performance. No one's site loads in under a second. My site is a static site. But you want to get it down to definitely under 3 seconds if you can. Doing an improvement of 20% within 50 milliseconds of idle time. That means if you're doing a heavy JavaScript, you want it to react to human interaction within 50 milliseconds. So you don't want any script to take longer than 50 milliseconds. A repaint should happen in less than 10 seconds to give 6 milliseconds for the page to draw to the screen, because anything over 16.67 milliseconds to redraw to the screen feels very janky. And then you want to also respond to user input within 100 milliseconds. If a user touches has anything, you want to inform them that you know that they have interacted with your screen. So one of the things we do is we measure certain features of a load process. And I highlighted the colors of DNS and TCP and DOM content loaded event, because when we watch the waterfall, that is what we look at. This is a terrible, absolutely horrible unconscionable waterfall. This is wired.com. Their DOM content loaded event is at 29 seconds. Their DOM content loaded was at 6 seconds. And all of that last pink thing there, that's one piece of JavaScript that means basically the main thread is being occupied. This doesn't matter whether it's mobile or desktop. This is bad user experience, right? If the user can't interact because the main thread is occupied, and by not interact, they can click a button and it doesn't show anything because the main thread is being used. So what I was trying to basically say is network and latency is actually partially under our control. So we just can't control the hardware and browsers. So how can we improve on all of those things? Here's my site that loads in under 1 second. It was a joke that I did for April 1st. Has anyone seen the movie Zoolander? Zoolander?
Yeah.
Okay. So this is the machine learning workshop, the insert logic for machines who can't learn good and want to do other stuff good too. I'm just glad someone saw Zoolander and someone gets the joke. Even if one person laughed, thank you. So it's a site. It looks like it's a Bootstrap site, right? Does this look like Bootstrap? I've never used Bootstrap. I don't actually know what Bootstrap would look like. But it's super fast, and let's talk about it. So that's the waterfall. This was before I actually finished doing my performance enhancements. So it finished loading, because for some reason there was Google Analytics that was put on it by GitHub. But basically it's pretty good. So let's talk about it. Let's skip this one. Okay, so, well, no, let's go back to it. Okay, so there are tools and rules. The original rule book was Why Slow. It came out in 2005 or 2006, and it was like 12 or 16 steps to make your website fast. Those are all valid still today. Everything that they said in 2006 is still valid. Then there's PageSpeed that came out, and then there's Web Page Test, and then there's developer tools, and then there's Lighthouse. Do you all know what Lighthouse is? Who here knows what Lighthouse is? Good, because I'm going to cover it, so I'm not going to bore everyone, because most people said no. So Lighthouse is a really good way to test your site and to get the hints on how to improve it, not just in terms of improving the general performance, but whether you're meeting best standards, whether your site is accessible, and whether it's a progressive web app. This site that I created does not need to be a progressive web app because it's a joke you visit once and you don't really need to have it on your home screen. Though I have it on my home screen because, so it's not a progressive web app. But the performance is pretty good, the accessibility is pretty good, and the best practices are pretty good. So what is Lighthouse? I'm going to open this up here. This is machine learning all on its own. And I'm going to open my developer tools. Cool. Here is the audits tab right there. And I'm just going to try to increase the size, which just hides everything. Bring it up. It says, it's audits tab, and it says Lighthouse. And I click on Lighthouse, and of course it's not going to work because the button's down here. And it gives you 4 options: progressive web app, performance, best practices, and accessibility. I'm just going to leave them all up, and I'm going to run the audit. What it does, if you can, well, I can't really load. It basically turns it into a mobile device and switches the speed to a mobile speed. It says, is it too wide? Can I save it on my home screen? Is it secure? All these other things. And you get a result, since we're not going to wait for it, that looks kind of like this. So the performance, this is shitty hotel Wi-Fi that I did it on earlier today. So the performance was at 61 because the time to first meaningful paint was 4.190 seconds because that's how long it takes to ping a DNS server from my hotel room, because I was actually pinging google.com and it was like 476 milliseconds or something crazy like that. So I'm not blaming myself for that, but that is something to think about. But someone who has shitty hotel Wi-Fi, all of the sites they visit, so your competitor's site is also going to be on that terrible Wi-Fi. So like, you want to make your website faster than your main competitor. And for bad jokes like Machine Learning Workshop, I have no competition, so I can actually be at any speed I want. A cool feature, I'm going to go back here, is right here, this little arrow. You can actually save the results. And you do want to save the results, because when you start working on performance, you want to do a pre and post and see how much you improved. So download it, say, like, call it pre-assessment.json, and it definitely needs to have the .json name, because then there is, let me just cancel this tool. There is this tool, nope. Yes, okay. So this tool right here is the Lighthouse Report Viewer, and you can just click this to get the URL, which is googlechrome.github.io/lighthouse/viewer, and you can just say, hey, that's my afternoon talk. Resources. Oh, there it is, right there, the JSON file. Open it up, and so you can look at it later. So that's a really cool feature of Lighthouse. Let me just go back to it here and go through a few things. So it basically checked whether it was a progressive web app. I didn't get a service worker because there's nothing for my service worker to do. I don't really want to do push notifications. Don't do push notifications. They're really annoying. And as Scott said, you don't want the toaster oven coming up at the bottom of your page. And one of the things you definitely want to check is the accessibility. And so this one, background and foreground colors do not have sufficient contrast ratio. And if you go to my, I think I just opened my email account by accident, so I'm just going to quit while I'm not too far behind. If you looked at that website, one of my titles, one of the things had a background image. And that background image went from dark blue to white. So any text I put over that is not going to be accessible because the contrast ratio is not good enough. But there are certain things you can do. I added a drop shadow, and I made the font much darker. And it's only one little circle of white. So most people can, without cognitive disabilities, can actually figure it out. And I decided that that was okay. I could live with that. Their guidelines, accessibility guidelines, they're not, you basically want to make it as accessible as possible. So let's talk about solutions. One of the solutions that our previous speaker could use, it's simply adding a viewport meta tag to their website, and then their website will be mobile friendly. One line of code does this. Alexa, when I tried loading it to see what the top 1,000 sites were, can anyone read the thing on the, someone has like 50-50 vision. That's what it looks like by adding that one meta tag. Person has to scroll, but at least the person doesn't have to zoom in and they can see what your site's about. Don't be a jerk like Gmail. Gmail has their web application says initial scale 1, which is fine. Maximum scale 1, which means they can't zoom in. Minimum scale 1, which means they can't zoom out. User scalable no, which is redundant because they just said no, you can't zoom. And width equals device width, which is the only line that they should have put in the first place. Okay. Second, so these are tips. The first one was viewport meta tag. One line, and you're already making it so much more accessible. Tip number 2 is to optimize all images. And this one has 7 sub-tips. So the first sub-tip is to gzip, which has no impact whatsoever on binary files, but if you're doing SVG, definitely helps. Remove image metadata, especially if you have a small image, but you're sending all of this extra data that no one knows about or cares, and also can be a security risk because you don't actually want to tell someone your exact location when you were taking a picture unless you want them to stalk you. Resize images. Serve the smallest image file for the screen size and resolution. And when you are resizing images, realize that the breakpoints for your images, the bigger the image, the more breakpoints you should have. In this example, this is actually a PNG. Thanks. This is a PNG, and when I had it when I served a 240 pixel image to a 200 pixel square, I was losing 17,000 pixels because that blue area is basically what I wasn't using, right? The image was actually the size of the blue and I was shrinking it. So I lost 17,000. When I got to the big one, it's only still 40 pixels difference, right? But look, it's 40 pixels of a over a huge length. So that was 65,000 pixels. That is a lot. So the bigger the image, the more breakpoints you want. Another thing about images is that they have to be decoded if they are resized. And they're decoded twice. So it takes more memory and more time to decode the image. So this was done by Tobin Titus at Microsoft a few years back. And he took an image when he served it right size and he served it wrong size. And the wrong size one, it was a huge image, by the way, took 1.8 seconds to load, and the right size image, that's why you know it was huge, took 0.6 seconds. But the thing to note is the bottom scale right there, that goes up to 100, that one line, and the top one is twice that size. So it's actually 4 times worse than it looks. The blue is CPU usage, and the green is frames per second. So definitely try to serve the right size image. Tip number 3 of section, or tip number 2, section 3, part B, is use a picture element. The picture element has the source child, which takes a source set attribute, which is what you give the image, and a media type. When you use the picture element, there's no reason not to use the picture element because 1, it's supported in almost every browser, but 2, you have to include the image tag with the default image. So it's always, if you code it correctly, you're always going to have a default image. IE5, if you're still supporting IE5, get another job. No one is. I'm just joking about that. But even if you're supporting IE8, get another job. And maybe 9 and maybe 10, or maybe IE in general, except for I'm friends with Scott, so I can't really say that. But there's also the source set attribute on the image tag. So you can use the source set attribute in the source element or in the image element. Okay, optimize all the images. No reason to send a higher resolution than you need. Use the right image format. There are many different formats. You never want to use GIF. You just don't want to use GIF. Use PNG8. It's a smaller file size. WebP, unfortunately, only works in certain browsers, but it's definitely the smallest that you can do. You can automate this, and the neat trick is, so here are the optimal image formats by browser. The neat thing is that if you set up your server right, you can actually process all of your images, you automate it, and then you don't even have to change the file name, so you don't have to update your HTML. You can send a PNG or a WebP with the .jpeg extension to Chrome, and Chrome will know, like, oh, the data type is WebP, and it will as long as it understands the data type, it will show it. So you can't send that image to Firefox, or maybe you can now, I didn't actually check their new support, or Safari. You do have to send like a JPEG 2000 to Safari or a JPEG to Safari, but you don't actually have to change your HTML, so you can serve the right image type. Where I used to work at Insert Logic, that was a service they provided, but you can set that up yourself. So you also want to reduce the number of images. If you don't need an image, don't use it. Use sprites. We have HTTP2, but that is not the save all that we think it is. And leverage CSS. I'd like to give this example of CSS, which is, this is a bunch of, the point of this one is transparent PNGs are enormously huge files, right? But sometimes you need a JPEG with transparency. If you need a JPEG with transparency, you can use masking, CSS masking. So in this example, if I get rid of the background image, well, let's do this. Let's get rid of the content. So this is the image, right? This is the actual image, but I want part of it to not show. No, actually, it's the other way around. But what happens is I have a mask. I have a phone, and I mask out the parts that I don't. I only mask. I put black on the parts that I want to show. So I have this background image of a phone, and I'm going to get rid of the mask right there, and that's what it looks like. But then I have a mask that is just a rectangle with an empty inside, and that allows the background of that to show through. So the background of this is cats, and I want to put like a frame around it. That frame would be 88 kilobytes, and now I'm serving an image that's like 9 kilobytes with a mask that is like 2 kilobytes. How I discovered this was I had an image that I needed to serve to an iPhone 4 that had one little tiny piece of transparency, and I could either have served it at a meg or at 88 kilobytes. So I went with 88. I thought that was a better idea. So support is all the WebKit and Blink browsers and Firefox, not Edge yet. Okay. So tip number 3, we finished the images part, that was tip number 2. Tip number 3 is optimize video. You can, what I'd like to, these dates are not 7 years apart, it's only 2 years apart. And the difference in the video is not visible, but it's right here. This is what it was like 2 years ago, and it's, I think, 725 kilobytes. And this is what it is now, 1,257. I think it's actually less than that. Oops. Right arrow. Nope. It's not going to show because today's not my day. Okay. So, step number 1 is omit the video. You don't really need that video behind your header, right? No one cares about the fact that someone is reading a book to their kid and you're selling bank products or something like that. Do you really need the hero video? If not, hide it. Hide it by the parent. Hero video display none. Media screen and mid-width 640. Or you can even use the navigator connection object, the effective type. Optimize the source order. So there's different video types are supported by different browsers, and different video types will actually be smaller or larger. So put the smallest one first, because when a browser hits one that a media type it understands, it stops downloading the other ones. So in this case, my WebM would be at 12 megs. Oh no, my WebM would be at 10 megs, which would go first, and would be served by the browser that understood it instead of the MP4, which would be at 12, versus the OGV, which would be at 13. So this is optimizing the source order, really easy way to do it. Check for quality consistency, because sometimes, like if you have a really crappy one, it might be just 1 meg, but it might not actually be a good idea to use that one. And then, most important, or such a low-hanging fruit, is remove the audio that is being muted. When you have that parent reading the book to a child as behind the carousel on the hero of a page, how many people play the audio on that? Not a single hand, exactly. But most people are actually sending the audio file along as part of that video file. So there's the audio within that track. This command right here, you just have to install FFmpeg, but that will actually just take the original and convert it to an audio-free version. You can automate that, get rid of all the audio files, and save 20% on your video. And tip number 4 is do everything else. Those were the lowest hanging fruit. The first one doesn't actually improve performance in terms of how long it takes the site to load, but it improves performance as in a user actually wants to stay on your website. Everything else has been time. So here are a few more things. Put the style sheet at the head, put the script at the bottom, even if you use async and defer, because you never know if it's going to listen to you. JavaScript, remember that you're wasting battery, and the more JavaScript you have, the more time it takes to parse and execute it. And you might also have long functions. So you don't want a DOM content loaded event of 2 seconds. Keep the way, don't let third-party scripts also be a single point of failure. And if you're using libraries, do you really need 16 libraries? No. Battery consumption. Think about it when you're developing. Avoid repaints and reflows. Avoid waking up the radio to check to see if your Facebook likes have increased every 1 second or every 100 milliseconds. Let the browser idle. Let your JavaScript idle every 50 milliseconds is how long. Don't have the 2-second DOM content loaded. I already mentioned that one. This is the Visa site. It's a form with 2 form controls. I'll talk about this in my talk this afternoon. Minimize the number of DOM nodes because every DOM node has to be measured every time you do a reflow. So it uses up memory and time. And remember that squishy is not responsive. So here, Disney went mobile by increasing the request from 77 to 123. That is squishiness, that is not responsiveness. They still had a 3.3 megabyte website. And HTTPS, Swift on security, Taylor Swift, of course, that's who it is, said, so here's the deal. Browser made a decision to refuse to enable any new advanced speed features moving forward for unencrypted websites. Move to HTTPS, even though it does take 3 times longer for the DNS, for the response, for the TLS handshake. Okay, consider progressive web apps. Definitely this is the way to go. Make your site work offline on the mobile device and not have to re-download everything every time. Avoid AMP. Yes, it might make your site faster, but they're evil. I blame AMP for Donald Trump's presidency because this is 3 weeks ago. I did a search for Obama during the week that he was doing the fundraising for Puerto Rico, and what came out is that Jimmy Carter, he let loose on Obama and Hillary and says that Russia did not alter the election. Is that real news? No. But that is an AMP page, and that is what is Google serving. Not only does it give preferential search treatment for stuff that is not actual news, it's based on whether it's AMP and not the content, but also the visitors remain in the Google ecosystem. So the URL that you will go to still has Google in it, except for it doesn't show that it's Google. So as you're developing, build with accessibility in mind, build with mobile in mind, test in real environments, not just your testing devices. Put Facebook in every slow app you have, Candy Crush on that phone while it's on when you test it, because that's using up memory. So test in a real environment. Scale down, not up. Take advantage of HTML5. Don't disable Zoom, except for games. That is the one exception to the disabling Zoom. Games, you can disable Zoom. So in conclusion, follow everything I told you today. Minimize latency, manage memory, use CSS judiciously. I didn't talk about that because that's a talk in and of itself. Batch query manipulations, batch queries and manipulations separately. Reuse a DOM, and mostly keep mobile in mind. And remember, your users probably are not tethered. Their memory may be limited, and they might be paying for bandwidth, and it might also be unreliable. So with that, I want to say thank you, and just give you the resources, which is I didn't talk about speed perception, but machinelearningworkshop.com if you want my joke and think it's funny. And this one right here is the book that was published 2 weeks ago, and it's 1,054 pages. It's CSS, the good parts, because everything in CSS is good. Thank you very much.